Okay, so chapter 10, we are going to be dealing with solving systems of linear equations. But first, we want to know what a system of linear equations are. So here, the solution of a system of linear equations is a point of intersection. So your answer is always going to look like an ordered pair, or the coordinate x comma y. So here we want to determine if the following represents a system of linear equations. If they do not, we want to explain why. Well, x equals 2, we should be familiar with this. This graph looks like that line. Y equals negative 3, we should also be familiar with that. Both of those are linear. Since both of those are linear, it's two equations, all right, that are linear. Therefore, this is a system of linear equations. So, let's look at the box below. Is y equals x and y equals x plus 5, is that a system of linear equations? Well, I have two equations because I have equal signs in both, and I have these same two variables. I've got an x and a y variable. There are no exponents, which means we only have the exponent of 1. Both of these I can graph. Both of these are linear. So yes, this is a system of linear equations because both are linear. This box right here, is this a system of linear equations? No, because there is only one equation. So we have to have two equations. It's two or more equations with the same variables. The big box at the bottom, this is a no, because there is only one equation. Let's go to the top right here. This is a graph that is linear. This is also linear. Okay, we've learned about linear earlier in the year in chapter 4, what's linear, what's nonlinear. Both of those are linear. We have two equations, the same variables in each equation. So yes, this is an equation because both are equations. Both equations are linear and have the same variables. This is not even an equation, all right? So no, because there are no equations. I'm going to go ahead and copy that because that also goes right here. This one is no because there's no equations. If there's no equal sign, no equation. Can't have an equation without an equal sign. All right, so let's determine if this is a solution to the system. Now, this is an ordered pair where that is x. The first number is always x, second number is always y. In order for this to be a solution, this ordered pair has to simplify in both of the equations. So let's substitute these values into the top equation. And then I'm going to simplify the right, 2 times 2, which equals 4. 4 equals 4, check. So it works for the first equation. Now let's check the second equation. Simplify the right-hand side here. 6 times 2 is 12. 12 minus 8 is 4. And 4 equals 4, check. So yes, because the solution works in both equations. Again, we have to test out both equations for this to work. So let's try this coordinate with these two equations. So x minus 4 equals negative 1. Let's simplify the left. 2 minus 4 is negative 2. Negative 2 does not equal negative 1. So right here we can stop and we can say that no, it is not a solution because the coordinates do not work in the top equation. Remember, when we simplify, it's got to simplify to equal. So let's try this coordinate, this ordered pair right here. I'm going to substitute these values into the equation. So 3 times 3 is 9, minus 4. 9 minus 4 is 5. 5 does in fact equal 5, so it works for the first one. Now let's check the second one. 3 minus a negative 4 should equal 7. Minus a negative means plus a positive, so let's be careful with those negatives. Does 7 equal 7 when we simplify both sides? Yes, because the ordered pair works in both equations. All right, now we are going to write a system to compare the lengths. We just want to write a system of equations. We should have some words here that look familiar. Initial and rate. Okay? Initial length should sound like initial value. So when we wrote equations earlier this year, linear equations, we did them in slope-intercept form where y equals mx plus b. B was our initial value, and m is our slope or our rate of change. So this top row here is going to be our initial value, bottom row, our y-intercept, or our slope, our rate of change. For the Greenland shark, let's write an equation here. Y equals 0.75x plus 37. We just substitute those values in. And now for the spiny dogfish shark, y equals 1.5 is our slope, x plus our initial value of 22. There is our system of equations right there.